The US military has just unveiled something the world didn't see coming: indestructible concrete warships. Stronger than steel, immune to missile strikes, and built to last for decades. These aren't just ships, they're floating fortresses designed to change how wars are fought and how power is projected. China's watching, NATO's reacting. And now everyone is asking the same question. Are these the future of naval dominance? In this video, we break down the science, the strategy, and why the entire world is suddenly panicking over a material most thought belonged in buildings. Stick around, this one's going to shock you. DARPA's indestructible concrete. It didn't take long for the US to respond. After China made headlines with its concrete warships, DARPA, the Defense Advanced Research Projects Agency, quietly unveiled something of its own, not just a countermeasure, a leap forward. America has developed a new type of military-grade concrete so advanced, it's already being called the next armor of the sea. Unlike the raw concrete used in the 20th century, this one is engineered at the molecular level. Stronger than steel, yet lighter than traditional mixes, resistant to salt water, freezing temperatures, and even missile strikes. In one test, a slab of this new concrete absorbed a high-velocity missile impact, split momentarily, then reformed, completely intact. DARPA scientists and contractors worked with top universities and materials labs to create this new mix. It uses a combination of smart nanomaterials, graphene, and fiber lattice reinforcements, all locked into a self-healing matrix. When damaged, the material activates internal capsules that release a binding agent to close fractures in minutes. One materials engineer said, "It doesn't break, it adapts." That's the difference. And while it may have started as a response to China, the US now sees it as a breakthrough that could reshape everything. Not just warships, but platforms, ports, and infrastructure. But the real game changer? It's not just what this concrete can do, it's how it's made. And that's where things get even more futuristic. Next, let's talk about how AI and automation are building the Navy's next generation without a single bricklayer on deck. Designed by AI, built by machines. The US didn't just mix better concrete, it reimagined how it's made. This time, artificial intelligence didn't just help design the ships, it helped invent the material itself. Using massive data simulations, DARPA's systems ran millions of combinations of cement, fiber, and nanostructure arrangements until they found one that was shock-absorbing, ultralight, and flexible enough to survive the sea. The result? A formula that no human could have discovered alone. Then came the build process. Instead of traditional forms or steel molds, the US uses 3D printing robots. These machines can pour and shape reinforced concrete directly onto floating docks or in mobile shipyards. No specialized workforce, no delays. The system uses GPS-stabilized platforms, auto-sensing tools, and onboard curing systems that adjust in real time to humidity and temperature. A Navy tech officer said, "We're not just building ships, we're growing them, and it doesn't stop with the hull." Embedded throughout the surface are smart layers, tiny sensors that monitor stress, temperature, or corrosion and pressure. The ship essentially self-reports its condition like a living organism. Combined with the self-healing chemical capsules inside, this concrete can survive impacts and repair itself all without human intervention. But this isn't a new concept out of thin air. In fact, it's a revival, a return to a wartime strategy that's been waiting 100 years to evolve. Coming up, we dive into history when concrete ships first set sail during a time of global crisis. Why concrete ships are back. To understand why this matters, we have to rewind. During World War I and II, steel was in short supply. The war industry consumed nearly every inch of it, forcing engineers to try something bold. Building ships out of concrete. It sounded insane at first. Concrete is heavy, it cracks, it's not sleek like steel. But back then, necessity drove innovation, and it worked. The US commissioned dozens of concrete ships, most famously the SS Peralta and the SS San Pasquale. The British, Germans, and Norwegians also built their own fleets. These ships weren't pretty, but they were practical. Immune to rust, invisible to magnetic naval mines, and cheap to produce. As one World War II engineer said, "We didn't have steel, we had cement, and a reason to float." Some of those ships still exist today, a century later, quietly serving as breakwaters and museum pieces. They've survived time, storms, and salt long after their steel counterparts rusted away. Fast forward to today, and the situation has flipped. Steel is expensive, cyber-targeted, and strategically vulnerable. Concrete, especially smart concrete, is now a deliberate choice, not a backup. And now, instead of just cargo ships, we're looking at floating bases, missile platforms, and command centers. But to build something that permanent, you need a material that's as tough as the ocean itself. Let's explore exactly what makes this concrete nearly indestructible in the next segment. What makes this concrete indestructible? It's not magic, it's material science taken to the extreme. The US military's new concrete isn't just strong, it's strategically smart. It's made to endure conditions that would destroy most ships in minutes. Pressure, salt, fire, cold impact, you name it. At the heart of this is balanced resilience. The concrete is dense enough to absorb explosions without fragmenting, but flexible enough, thanks to carbon fiber reinforcement and nano-adaptive lattices, to flex under high stress. One DARPA chemist explained, "It bends before it breaks, and even if it breaks, it fixes itself." AI simulations helped engineers fine-tune the pore structure, the microscopic air bubbles inside the mix, to maximize water resistance and pressure tolerance. This means it won't crumble from saltwater corrosion or deep-sea stress. Tests have shown it can survive direct torpedo impacts, intense fire exposure, and freeze-thaw cycles in Arctic environments. The material adapts to thermal expansion and contracts without cracking. Even more impressive, it maintains its strength for decades with little to no maintenance. All of this means you can station a platform or vessel anywhere in the world, and it won't need repairs for years, maybe decades. That's not just durability, that's dominance. But what happens when this durability meets scale? When you're not just building ships, but entire floating installations? That's where we go next, into the world of unsinkable mega platforms. Floating fortresses and mega platforms. What the US is doing now is bigger than ships. It's about ownership of the ocean. Using this new concrete, military engineers are building modular platforms, massive floating structures that can act as air bases, radar stations, drone ports, or missile hubs. Think aircraft carriers, but wider, flatter, more stable, and harder to destroy. These are floating fortresses. Some of them are designed to interlock, forming vast military hubs at sea. Others are built as independent strike islands, capable of launching drones, intercepting missiles, or hosting aircraft without ever docking at a port. One naval strategist called them real estate that sails. And unlike steel warships, which need constant maintenance and dry docking, these platforms are self-sustaining. They require fewer crew, can house AI systems, and resist everything from corrosion to sabotage. Early trials have already shown success in remote waters near Alaska and the Pacific Rim. The US Navy sees this as a way to stay present in disputed waters, without ever needing to ask for permission. The age of floating cities and military hubs may sound like science fiction, but with concrete this durable, it's already happening. And with presence comes power. Next, we'll look at how this tech could reshape global control of oceans and territories, reviving America's maritime dominance in regions long contested. The return of maritime supremacy. The United States has always seen its Navy as a symbol of strength. Aircraft carriers, destroyers, nuclear subs. They don't just patrol waters, they project power. But times have changed. Now, with the rise of near-peer competitors like China, the old rules of sea power are under pressure. That's where these new concrete warships come in. Unlike traditional vessels that rely on speed or stealth, these ships are about permanence. They can sit in one location for months, maybe even years, without degrading. They can operate in rough seas, frigid climates, or contested waters with minimal support. In strategic zones like the South China Sea, the Arctic, and the Indian Ocean, the message is loud and clear: we're not leaving. What makes this particularly game-changing is that these ships don't require traditional port infrastructure. They can deploy anywhere, stationed like man-made islands. That eliminates vulnerabilities, like being dependent on allies for docking rights, or needing massive naval bases near volatile regions. A U.S. admiral recently said, "With these vessels, we bring the base with us." And that changes everything. Not only does it reinforce territorial presence, but it allows for on-site operations, air defense, surveillance, drone coordination, and even missile launches, without the risk of losing a single piece of critical infrastructure. The era of floating dominance is here, but America's move has stirred more than curiosity. It's raised serious concerns across the Pacific. Next, let's take a closer look at how China is reacting to this unexpected counterpunch. A silent tech war at sea. From the outside, it looked like business as usual. When the U.S. military unveiled its indestructible concrete ship technology, Beijing's official response was silence. No major press conferences, no speeches, just a short mention in state media, brushing it off as a standard materials advancement. But behind the scenes, something else was unfolding. Inside China's military circles, there was real concern bordering on urgency. On the country's biggest defense forums and military analysis blogs, the tone was very different. Writers dissected every available satellite image of U.S. dry docks. Analysts compared newly filed U.S. patents with leaked engineering blueprints. Rumors started to swirl. Was the U.S. now a full generation ahead in military concrete technology? One article posted on a Chinese defense blog read, "The oceans are becoming immovable." Another warned, "Concrete is the new aircraft carrier." Why such alarm? Because China had assumed it was leading this race. It had invested heavily in South China Sea fortifications, using advanced concrete to build artificial islands, runways, and radar towers. But now the U.S. wasn't just reacting, it was leapfrogging. And that sent shockwaves through the very labs and agencies that thought they had a monopoly on seaborne permanence. Reports suggest China's naval R&D units are now racing to upgrade their mixes. They're reportedly exploring hybrid concretes that include titanium mesh, rare earth binders, and even carbon foam cores to balance weight and density. According to military insiders, they are fast-tracking a new line of test vessels under tight secrecy, aiming to match or exceed what DARPA has created. But this battle isn't happening on sea or in the air. It's happening in labs, servers, and test tanks. It's a war of composite molecules and structural memory, not missiles and cannons. And that changes everything. This new front in the US-China rivalry isn't about how ships fight, it's about how they're made, how long they last, and where they can operate without fear of destruction. Naval supremacy is no longer just about fleets on the move. It's about immovable, permanent presence, ships and platforms that become part of the ocean. As one Western analyst put it, this is infrastructure warfare. You're not just fighting where the ocean is, you're building where it wasn't. And that has profound implications. Because once the US or China establishes a permanent outpost somewhere offshore, whether for surveillance, drones, or missile defense, it's almost impossible to remove it without an act of war. These platforms become like military embassies in the sea, constantly watching, constantly defending. But China isn't the only nation watching this unfold. Across the Atlantic, America's traditional allies, some of the world's most experienced naval powers, have just been caught off guard. And now they're moving quickly to get back in the game. Let's head to Europe, where NATO is rethinking its entire maritime strategy and asking how to turn this concrete revolution into a shared front for Western resilience. NATO allies rush to adapt. For decades, NATO relied on U.S. naval leadership to project security across the Atlantic, the Mediterranean, and the Arctic. But as this new concrete technology emerges, European powers are no longer content to watch from the sidelines. They want in. The United Kingdom, France, and Germany have all expressed interest in joint development programs. The idea? Incorporate America's ultra-durable concrete into new military installations, especially in regions vulnerable to conflict or climate change. Think floating command centers in the North Sea or modular platforms in the Baltic ready to be deployed at a moment's notice. One French defense minister recently said, "We no longer build walls, we build permanence at sea." And it's not just about defense. European nations see these concrete platforms as a way to protect shipping lanes, respond to climate emergencies, and even monitor Russian or Chinese movements without needing fixed bases. There's growing talk of using these platforms to anchor NATO's presence in contested zones without violating territorial waters. Because if you can float a base outside of someone's jurisdiction, and it's unmovable, it changes how international law is interpreted. The implications go far beyond war. Because while concrete platforms can carry weapons, they can also carry infrastructure. And that's opening doors far outside the battlefield. Coming up, we explore how this military tech is moving into the civilian world, fast. Infrastructure that resists everything. At first, it was just about ships, then platforms, then bases. But now, the same concrete technology developed for the US Navy is being eyed for something much bigger: our cities, roads, and homes. Across the United States, engineers and architects are racing to apply this military-grade mix to critical infrastructure. Think hurricane-resistant hospitals, fireproof buildings, earthquake-proof bridges, and highways that heal themselves after a winter freeze. Why? Because the properties that make these ships indestructible, self-repair, thermal stability, or corrosion resistance, solve the very same problems plaguing our cities today. A FEMA official said, "This is the kind of resilience we need in every flood zone." Disaster-prone areas like Florida, California, and coastal Texas are already testing the concrete in civil projects. There's talk of deploying it in underground bunkers, levees, and emergency relief centers. The Pentagon is quietly coordinating with civilian agencies to provide blueprints, technical data, and material samples, marking a rare crossover between military innovation and public infrastructure. It's a powerful symbol. What was built to survive, missiles could now save lives during hurricanes. But behind the optimism, a bigger question looms. Because while everyone's focused on what can be built, the real competition is about who will build it first. Let's step back and look at the bigger picture. A new global war is quietly taking shape. The materials war has begun. We used to measure military strength by warheads and submarines. But today, the quiet race isn't about destruction, it's about construction. The United States, China, and soon dozens of other nations are entering what experts now call the materials war. A competition not for land or weapons, but for the smartest, strongest, most adaptable building blocks of tomorrow. Universities are receiving record-level funding for AI-driven concrete modeling, self-healing composites, and hyper-resilient polymers. DARPA has issued new calls for material science breakthroughs, and major contractors like Lockheed and Raytheon are retraining defense engineers to design infrastructure, not just weapons. As one DARPA insider put it, the next war won't start with a missile, it'll start with a material. In this new landscape, whoever controls the innovation pipeline, from lab to launch pad to port, wins. It's no longer enough to be first in the air or undersea. You have to be first underground, above water, and embedded in every structure. This is how superpowers are now positioning themselves, not just by being seen, but by being built into coastlines, shipping routes, and urban zones that can't be moved and can't be ignored. And this changes everything. Up next, we look back to go forward at how lessons from 100-year-old concrete ships are guiding the next century of naval dominance. Lessons from World War II's concrete fleet. Before the world went digital, before AI, drones, or stealth coatings, concrete ships already had their moment. During both World Wars, the US, Germany, and Britain built fleets out of cement. Why? Because steel was too scarce and the demand for ships was overwhelming. Those early vessels were rough, bulky, slow, but they worked. The US alone commissioned dozens of concrete ships. Some carried oil, others served as barracks or floating mess halls. And a few, like the SS Peralta and SS San Pasquale, are still afloat today, their hulls largely intact after more than 100 years. One even served as a hotel, prison, and military lookout station over the course of its life. A naval historian once said, "They weren't elegant, but they were eternal." And that's the point. These ships weren't designed to impress. They were built to endure, to stay alive longer than the wars they were part of. And that's exactly the lesson the US military is applying today. Modern steel ships may be sleek and fast, but they're high maintenance and vulnerable to magnetic mines, corrosion, and hacking through electronic systems. Concrete ships, on the other hand, are non-magnetic. resistant to rust, and increasingly digitally independent. Now, with smarter materials, AI monitoring, and self-healing chemistry, the military is taking the same concept and upgrading it for the next century. The new fleet isn't replacing steel, it's outlasting it. And yet, no technology is perfect, which brings us to a critical question. What are the risks? Is this just a shiny new promise, or could it backfire? Let's examine what still needs to be answered. Risks, costs, and the unknown. For all its strengths, the U.S. military's concrete revolution isn't without serious trade-offs. These ships are built for the long haul, but getting them to sea comes with real challenges. First, cost. Advanced concrete isn't cheap. The materials, graphene, smart fibers, self-healing agents, can drive up the price well beyond traditional steel ships. And even with 3D printing tech, construction still takes time, precision, and highly trained robotics teams. Then there's the issue of weight. Concrete vessels, even the new ones, are still heavier and bulkier than steel. That means higher fuel consumption, unless carefully balanced with propulsion systems. In long-range missions, that could limit how often these ships are deployed or how far they can really go without support. And finally, repair logistics. While the self-healing function works well for microfractures, what happens if a major section gets damaged during conflict? These ships can't be welded in the same way as steel. Remote or wartime repairs may require new kinds of solutions that still aren't battle-tested. As one naval strategist admitted, it's a bet, a powerful one, but still a bet. The Pentagon knows this, but they're playing the long game, trading short-term agility for long-term resilience. And that brings us to the final chapter. This story isn't just about ships or science. It's about control of the future. Who builds it, who owns it, and who survives in it. Let's tie it all together. Who will build the future? In the end, this isn't just about warships made of concrete. It's about something bigger. Foundations. Who lays them? Who controls them? And who stands on them when the dust settles? For decades, the race between superpowers was measured in weapons. Missiles, nukes, jets. But now the race has shifted to something quieter, more permanent. It's about what nations are made of, literally. Concrete is no longer just a material. It's a message, one that says, we're here to stay. From U.S. naval outposts to Chinese island bases, from floating ports to underground bunkers, whoever builds with the strongest, smartest materials will shape the map of the 21st century. A DARPA researcher recently said, the wars of tomorrow won't just be fought, they'll be poured. The United States has taken the lead for now, but China is catching up fast. NATO wants in. Smaller nations are racing to develop their own variants. Universities are competing. Startups are pitching. The concrete arms race is on, and it's just beginning. So what happens next? Will this new technology usher in a stronger, more secure world? Or will it simply set the stage for the next generation of silent conflict, where permanence is power and infrastructure is everything? One thing's for sure, the future won't be decided by who shouts the loudest, but by who builds the longest-lasting foundation. And the only question left to ask is, who will pour the future? So there you have it. The U.S. isn't just building ships, it's building the future. What do you think? Genius move or risky gamble? Let us know in the comments. And if you enjoyed this breakdown, hit like, subscribe, and turn on notifications. Thanks for watching, and we'll see you in the next one.